This is the variables tier list. We got Latin variables, we got Greek variables, and we got sim it's not just variables. This also represents symbols and everything too. So let's get into it, right? What better place to start than with A, right? So I got my Wikipedia page, Latin letters used in math, science, and engineering. Um, to kind of help guide us through this. All right, so what do we got for A? We got first point of a triangle, doesn't really count. Digit 10 in hexadecimal. It's okay, I guess. Ampere, that's big. I think that's important. Here's a big one. Here's a big one. This is capital A. I'm not distinguishing between the uppercase, lowercase, anything like that. It's all the same to me. Um, so we got the area of a figure, right? That's big, right? I mean, who doesn't use that? That's not even something that mathematicians, scientists, and engineers use every day. That's something everyone uses every day, right? So already looking pretty good for A, and we're only at the what fourth little point on here. Mass number or nucleon number of an element. I like that. That's a good one too. Um, I'll speed through the rest of these. Anything else too important? Work in classical mechanics. I'm not gonna lie, I've never seen. I always just use W for work, so I don't really get that one. Um, the Arrhenius equation. I think that's important in like chemistry. I haven't really used that one, but I'll give it some points for that. A blood type. That does not count. All right. Anyway, let's go into lowercase a here. And again, I'm grouping them all together in the ranking. So we got triangle doesn't really count. Okay, here's a good one. Acceleration, right? That's another one that maybe not as commonly used as area, right? But everyone, in STEM is going to use acceleration at some point, right? And I mean, people in real life are going to be using acceleration too. Every time you get in a car, right? That's going to be kind of an important thing. So we got two heavy hitters with the acceleration in the area. What else do we got? Constant in the linear equation and constant polynomial doesn't exactly count. Um, the rest of these are not too interesting, but I think mainly just for the acceleration and the area, and a couple other good things here. I like the mass number. Um, I like amps. So with all of that, I don't think there's any other place to put it besides A tier. I know, a little bit cliche since it's A and this tier is A, but I think that's where I'm gonna have to put it, right? Okay, so B, right? I'm by the way, I'm sorry. I don't know who made this tier list. So sorry that the letters here are all different sizes. But let's go to B, right? Um, okay. We got the hex one. There's a couple trends I think we're gonna see here. We're gonna see hexadecimal all the way up until I think it's F, and then points on a triangle. This is why I'm not exactly counting these. A ball. That's new. Is that a math thing? I mean, I know what a ball is, like like in real life. I don't know what they mean by a ball in math though. Okay, it's a sphere, I guess. I don't know. I'm not smart enough to understand this, but that doesn't really count. Magnetic fields, that's important, I think. Yeah, I like the magnetic field. Um, what do we got? Blood type? No. Boron. I don't know if chemical elements really count. I want to lean towards the fact that they don't, because I'm talking about seeing them in equations. And I guess you could have a reaction equation that has the chemical element, but that's a little bit different. So I'm leaning towards chemical element symbols don't really count towards these variables and symbols. Um, Buoyancy, bulk modulus. Okay. Um, Impact parameter. Um, hmm. Molality. Barn. I like barn. It's a good unit. Um, I'm not gonna lie though, none of these are that interesting. I mean, there's B is certainly not useless, right? These aren't that interesting though, all things considered. So I think I want to go ahead and put it in C tier. And honestly, I'm kind of tempted. I might push it down to D if we see some really good variables. It's definitely not as good as A, both the tier and the variable, right? So yeah, we're gonna keep it in C for now. But speaking of C, right, our next letter is also C. So let's take a look at that, right? So, what do we got? Coulombs. I like coulombs. As a unit. Capacitance. That's good. And another thing we got to give C credit for. Most of these, symbols that C represents also start with C, right? Because when you have all these Greek variables that represent symbols, I mean, none of the words we use start with Greek letters, right? Because we're not speaking Greek, right? But sometimes there's a little bit of sense to it, right? Like epsilon and something that starts with E, they both start with the E sound. But, I got to subtract a couple points for that. Point is, C is very consistent about, that um, analogy where the C represents a quantity that starts with C. So we got circumference. I mean, that's pretty big on itself, right? I think, everyone has used circumference at some point, right? That's like what, third grade math? Celsius is also a pretty important, thing. I mean, you can see by the map here, we're the only ones. I mean, assuming you're American or Liberian, we're the only ones who don't use Celsius, right? So yeah, shout out to Celsius. Heat capacity is also a pretty good one. I'm not gonna lie, I'm pleasantly surprised here by C. These are pretty good um, representations here. The speed of light, okay. These are these are good. I've never seen it used to represent the speed of sound, but I mean, this is a lot of good ones. I wouldn't say any of them are as important as area, but I mean, what would we got? Circumference, Celsius, speed of light. Um, those are all pretty important. That's definitely going in A tier. I kind of am a little bit tempted to put in an S tier, but that's a good one. Okay, D. D, what do we got? The diffusion coefficient. Okay. I think a lot of different fields would use that, but that's not something you would talk about with anyone on a daily basis, right? I can't remember in any conversation I've had where I've had to bring up the diffusion coefficient, but I think in a lot of technical fields, that's important for different reasons. I may be wrong about that. Um, dimension deuterium D meson. I've never even heard of that. What's a D meson? Lightest particle containing charm quarks. Wow. Oh, there's a whole list of it. Wow, there's a lot of D mesons. Okay, you learn something new every day. Shout out to the D meson. I've never seen D used to represent density though. Yeah, even in its own Wikipedia article it says rho. So that I'm not counting that for D at all. Um, differential operator, the unit of time, day. Yeah, I guess that counts. Diameter of circle. There we go. That's a big one. That's a big one. Um, thickness, kind of. I mean, I use all sorts of things for thickness. I use T, X, L, um, D sometimes, I guess, but that's not really a great argument. The differential operator. Okay, this is. I don't know if I should count this. I don't know. I guess I have. If I'm gonna count the other stuff, I guess I gotta count that. Um, the differential operator. Okay. That feels like cheating though, because if we have the differential operator, if we have day as unit of time, and if we have diameter, this has got to be S tier. Um, but I'm not feeling it being S tier, so I'm gonna put it in A. I know everything's pretty much an A so far, but I think we're gonna get some worse variables the further we go. I don't think anyone's out here using O as a variable, so don't worry. We'll have some pretty low quality variables here in a second, but in the meantime, let's get to E. All right. Um, the exponent, I'm not gonna count it for the exponent, or Euler's number or whatever. That just feels wrong to me. Energy, though, we have to give it something for energy, and that's a huge thing. That's a huge thing. Everyone uses energy. Um, and most of the things on here are different types of energy. We're not really going to distinguish. The electric field also is pretty important. Electrons, I'll give it some credit for Euler's number. All right, I think E is S tier. Those are all pretty great. I'm a big fan of energy, so that already I'm partial to it. But in the meantime, let's take a look at F here. So we got the unit farad of electrical capacity. I'm not really crazy about that. Force, yeah, obviously. Force is big. I think I like energy more than force, but no one's gonna knock force. Also, I don't know why they have an F here and a F that's kind of slanted right here in like italics, but I don't know. This is why I'm not distinguishing between the cases because we would be here all day. Um, F to represent a function. I don't really know how I feel about that. F to represent friction, I guess. Really, I'm not feeling much besides the fact that it's used to represent force. So I want to put it here. If anything, I use mu to represent friction, the friction coefficient, more than I use F. So yeah, force is big though, so I couldn't put it lower than C tier. And I mean, there's a couple other things on here that are a little bit important. Okay, G. Bunch of math stuff that I don't understand. Graph groups. Gravity, that's, um, yeah, gravity's big. The Einstein tensor. I don't know how people understand this stuff. I really think the only convincing thing here is just G 9.81 meters per second. I guess big G can also represent, the gravitational force. But, force and the gravitational acceleration, on Earth, those are both the same, two sides of the same coin. They're both representing gravity in some form or another. And I think that's all G has going for it. And I mean, if that's all it has going for it, I can't put it lower than D tier, but I gotta put it at D tier, right? Because there's nothing else that's bringing it up. I'm sorry, G, you're not a G here though. Okay, H. Hilbert space, Henry, homology. This is what I'm saying. Tons of math stuff. Harmonic series. Hamiltonian is kind of important. Um, Not really feeling most of these though. I'm not gonna lie. The entropy of information, that sounds interesting. What is that? Average level. I don't know why I opened these Wikipedia pages to look at them for 5 seconds and then not understand it at all and be like, oh, that's cool. It's not really useful, but um, why is it called Shannon's? That's what I'm interested in. Was the guy who invented it just, that's our That's our question for the day. Okay, it's introduced by Claude Shannon, and I guess he was had a big ego, so he called the units Shannons. Got it. Um, what else do we got? The Hubble constant. Oh, Planck's constant. That's pretty important. If you're a nerd, right? No, I mean I like the Planck's constant. And it does represent an hour. I feel a little bit, it feels a little bit wrong to include the units of time like hours, days, and seconds in here, but I'm not going to weigh those very heavily. But besides Planck's constant, I don't think there's much going for H in my opinion. So might be sitting there with G in D tier. Okay, I try not to use I just because it looks like a one, but I'm sure there's some imaginary numbers right off the bat, right? That's pretty important. Um, the identity matrix, intensity, current. These are pretty good arguments, actually. Inertia, the moment of inertia. Okay, yeah, those are all pretty important. Moment of inertia, intensity, imaginary number, right, and current. Those are all pretty important. You know what? I may have underestimated you. That's deserving of A tier. Um, okay, J. Joules. Okay. Current density. Eh. Also the moment of inertia for some reason. I've always used I. Angular momentum. Oh, quantum number. Okay. Because I was like, angular momentum's L. Bessel functions. Impulse. Okay. Sometimes used to represent an imaginary number. Um, hmm. These aren't bad. It really is not. It's kind of I, but worse, right? Current density instead of current, you know, using it to represent the square root one if I is already taken, because you're already using that to represent current. Um, I guess Bessel functions, but those aren't that important. Yeah, this is just a dollar store version of I. That's going C tier. Sorry, J. Okay, K. Kelvin. Functors of K. What is a functor? Yeah, I get the point. Okay. Kinetic energy. Anything else? The Boltzmann constant? Yeah, I guess. Um, oh, yeah, yeah. The wave number, right? That's big. Um, Spring constant. Yeah. Okay. The unit, I don't know how I feel about giving it the unit vector. I guess both I and J also had the unit vector, and I didn't even mention those. Um, yeah, I don't really know what to think about K. None of these are really blowing my socks off here. Um, I think I might just have to give it a C tier. It's fine. Um, yeah, it's fine. Nothing is really tickling my fancy. L. I think we're gonna have I have high hopes for L. Length used often in quantum mechanics. I think length is used often in everything. I don't know. I don't know what this list's obsession with quantum mechanics is, but yeah, length. That's one of the few things that everyone's gonna use. Um, so I got to give it a lot of points for that right off the bat. And then angular momentum's also like pretty uh, relevant. Leader, yep. A formal language consists of words. What? Okay. Lagrange function, okay. Mainly just length and a couple other things. I mean, it has quantum numbers, the angular momentum quantum number, angular momentum, Lagrangian, mean free path. That's basically just a length though, so I guess I can't really give it any more points for that. That's what, B tier? Yeah, I'll give it B tier. Okay, M. What do we got? Manifold, metric space, matroid. Okay, it's already losing me. Never seen it used to represent torque. I think we're missing the big one. It's just mass, right? That's that's the really big one. There doesn't seem to be a lot of other convincing uses for it here. Um, oh, y equals mx plus b, slope, meter, sure. Magnitude, I don't know about that. Minute, sure. Yeah, but the SI abbreviation is min. So I don't think we can give it minute, right? Because it's not caring it all by itself. It needs an I and an N to represent, the whole thing. Um, hmm. Mass and meter, I feel like, are the real convincing parts of this, and slope, I guess. Mass, meter, and slope. Those are things that pretty much everyone's going to use. And that's three things that everyone's going to use. I got to give it A tier for that. N. Here we go. Newton. Normal vector. The Avogadro constant. Okay. Avogadro's number. A neutron. Cool. Number density. The principal quantum number. These are all pretty good. Yeah. Just the fact that it's used to represent a number of things is a pretty convincing argument. But it just doesn't hit the same as M does. And you know what? I want to move M up to S tier. Sue me, but M is great. So N is going to go B tier because it has some convincing points, but it's really not, it's not amazing. Okay. Oh, I think we're finally getting into our really low tiers here. Big O notation. Okay. O blood type, oxygen, and the origin. I mean, I guess those have some use, but I still got to put this F tier. You can never use this in a regular equation, right? Because everyone's going to think it's a zero. So yeah, I'm sorry, O, but you're going to be our first F tier of the night. Okay, P. What do we got? Pressure. Important, right? Pressure is big. Probability is also big. Power is also pretty important. I usually, and I don't know if this is a controversial opinion, I usually just write work with a dot over it. Or sometimes I just even write Q. So I don't actually use P to represent power that much, but I'll give it some points. Weight, that is a bold, that's bold. I've never seen P used to represent weight. Okay, sure. I'm really just probability and pressure are the main two things holding me up right now. Protons, yeah, protons are important. Momentum and perimeter. Pressure, momentum, perimeter. What was the other one? Probability. Oh yeah, those pressure, momentum, probability, and perimeter. Those are all pretty important. I don't know if they're important enough to give it an S tier, but actually they're important enough to to give it an S tier. Congratulations, P. You joined the club. Okay, Q. What do you got? Q. Heat. Um, yeah, heat's pretty important. I don't really understand who came up with that, but maybe we're just all hating on the H hate train. So we just decided not to use H to represent heat. But good for Q that it landed that. Um, Volumetric flow rate. Yeah, rho GQA. Yeah, I guess. That's another thing. I don't know who came up with that. Um, I don't know if there's anything else that's too convincing. The quotient? Yeah, no. I've no. Deceleration parameter in cosmology. What the hell? What? Okay. Sure. Oh, charge. Yeah, electric charge. I guess that's pretty important. So I'm really looking at heat and electric charge and volumetric flow rate is what we're really paying attention to. And I guess heat is pretty important. I guess heat is pretty important. Um, so I'll give it C, mainly just for that. Um, yeah, that's a C tier. Okay, let's look at R. The Ricci tensor. Ricci? Looks like Ricci. I don't know. Yeah, Ricci. He's Italian. Okay. Anyway, I have no clue what that is. The gas constant, sure. And resistance, electrical resistance. Okay. Radius. Yeah, that's pretty important. And separation of two objects in coulombs. Okay, that's just a radius. Position. Okay, sure. So we got, radius and resistance are really the two main things. Also, pretty important. Um, Radius and resistance. I think it's C tier. I think it's C tier. It's kind of in the same situation as Q, where there's a couple like mid-level, relatively important things like heat or whatever else Q represents, right? Um, but it's not blowing me away. Okay, let's look at S. The unit sphere. I don't know about that one. Entropy. Okay. I've never seen it represent area. Oh, unless if it's like surface area, maybe. That doesn't really count though. Displacement, second. Okay. Yeah, really only getting entropy from this one. Um, hmm. I don't know. Entropy and maybe a second. I don't feel great about giving them the time units. I already put H, which stands for hour, in the D tier, so I'm gonna have to put S in the D tier as well. S is really not doing it for me. Sorry. Okay. T. A tree. That's good. I guess trees kind of look like T's. Uh, because they have branches. But temperature is important. Time is also important, right? Torque is somewhat important. Kinetic energy, I think some people, I think you use it to represent kinetic energy in like a Hamiltonian or something, but I've never actually done that, and I don't really care, so I'm not giving it points for that. Tension, maybe. Um, the half-life, that's kind of a time, so that doesn't really count. Yeah, I'm really thinking this is just about time, temperature, and to a lesser extent torque. And time and temperature, everyone is using those, right? Um, those have got to be some of the most used like variables, period. So I think I gotta put it in A tier just for that. And I would put it in S tier, but none of the other things here are really interesting me that much. If it had a couple more important or more kind of interesting offshoots, I would give it an S tier. But I think I'm gonna leave it at A for now. Okay, U. Let's see what U represents. Internal energy. Okay, uranium. Shout out uranium. And velocity. Um, None of those are that great. I'm sorry, you're going in the D tier. V. I have high hopes for V, but we'll see if it disappoints. Voltage is pretty important. Volume is huge, and velocity is also huge. Hmm. Voltage, volume, velocity. That's enough to put it in A tier. Is there anything that's going to give it the S, though? Set of vertices, I don't know about that. Vanadium, I don't. Does anyone use vanadium? I've never really heard of a good use of vanadium. I may be completely wrong about that, but whew, I'm just not seeing anything too great besides velocity and volume. Um, and if I put T in A tier, then I'm also gonna have to put V in A tier. Um, yeah, I'm sorry, but really not blowing me away with that. Okay, let's go to W. So we got watts, okay, work, and not much else. Width doesn't really count. Weight, um, I guess. I usually just use mg for weight, but yeah, I think we just got work and a watt, and neither of those are too inspiring on their own, so that's a D tier. Um, of course, there's the Wiener process too. We can't forget about that one, but um, maybe next time. Okay, X, right? I so right off the bat, X is like the variable. If you're gonna put a variable in the equation, right, it's X. So I'm feeling at least a C just for that. But let's look at what it represents here. Yeah, a random variable, first thing. So good for X for that. Rate of change. Um, there's actually not that much here. Realize value of random variable, an unknown variable, the whole x-axis, that makes sense. A mole fraction, yeah, I gotta say I'm a little bit disappointed with x, but I want to give it B tier anyway, because, shout out to x. Okay, y, what do we got? Why are there so many different things that represent Bessel functions, man? I've seen y, j, L maybe, I don't know. Gross domestic product. Okay, we got some economics variables in here. Good for them. I haven't really seen any else. Maybe I haven't been looking hard enough. I haven't really seen many other economic variables, but okay, cool. Yocto. Never had to use that one. I don't know who would. That seems very niche if you're dealing with values that small. The y-axis. Okay. So all I'm really seeing here is the GDP and the y-axis. Both are pretty important, but I don't know. I'm kind of feeling a D tier for this one. Actually, no, I'll give it a C tier. It's because it is the second variable, right? If you don't have x, you have y. It's just it's kind of the epitome of a variable in some respects. It's just a worse version of X. So, yeah, I'll give it C tier. Z. Okay. The atomic number. Okay. Electrical impedance. Um, okay. And the z-axis. Z buffering. Cool. Redshift. Interesting. I haven't seen it used to represent that. But I guess I haven't done a whole ton with redshifts, so I wouldn't know. And the collision frequency, these aren't great. These are not great. Besides the atomic number and the z-axis, this is just going to be, yeah, that's D tier. Sorry. I mean, it's kind of the trend, X, Y, and Z, right? Each one's a little bit worse than the last. Oh, yeah, I forgot that's the end of the alphabet. Okay, so let's take another look at our Latin letters here before we go Greek. You know, I'm gonna move T up to S tier. I just realized that I love T, and I don't actually know why I put P in S tier. It was parameter, pressure, momentum, and something else, right? We're doing this. That's just the vibes. This looks more like what the tier list should look like. Maybe I'm forgetting something that made P great, but this seems more correct. Yeah, cool. Let's go on to the Greek letters here. Okay, here we go. Alpha, right? Um, First angle, okay, false positive rate. Got it. Um, Angle of attack. I'm kind of liking even the ones that I'm not really familiar with here. I am kind of liking them. Angle of attack is interesting. Fine structure constant is interesting. False positives are interesting. Alpha particles, okay. Thermal expansion coefficient, diffusivity. Um, okay, cool. There's a lot of stuff here. And none of them, I'm not gonna lie, none of them are huge. None of these are really blowing my socks off. But um, there's a couple good ones. And by a couple, I mean a lot. There's a lot of good, kind of like more niche variables here. And I gotta say, that makes alpha a very interesting variable, and that makes alpha, oh, is it A tier? Is it B tier? Um, I think it's A tier. I mean, is an alpha, right? And it really looks ginormous. The picture I used here. I mean, whoever made this tier list used. Whoever made this tier list clearly didn't size everything right, but cool. That's the wrong. You know what? Let's just close that one out. Okay. Beta. Um, cool. Beta. Another angle. Okay. False negative rate. Cool. The beta is kind of seeming like a slightly worse version of alpha, you know. Like false negative versus false positive, beta particle versus alpha particle. Um, yeah, but that's not to say beta isn't good. There is a lot of interesting things here. Um, just not nearly as interesting as alpha. In fact, not even just a tier less, 2 tiers less interesting. Sorry, beta. Okay, gamma. Here we go. Um, Circulation and fluid dynamics. I've never seen that. That's interesting. Um, cool. The gamma function, a generalization of the factorial. Ah, nice. Um, I'm not gonna lie, all the capital gamma stuff is not great. I'm sorry. Specific weight, okay. It's actually not that interesting, but okay. Um, Gamma rays, right? That's pretty big. The Lorentz factor, I like the Lorentz factor. The heat capacity ratio, I guess, is kind of important, but yeah, I think there isn't a ton going for this. Uh, C or D tier. I'm sorry, this is D tier. I'm sorry, Gamma. Um, Delta. So right off the bat, the difference is pretty big, right? Difference is pretty big. So yeah, um, that's probably going to do the bulk of the work. But also, yeah, the Laplace operator and doing the gradient and everything like that. That's pretty important. I guess that's an upside down delta. Um, but you know, it's the same thing at the end of the day. Um, okay, that's delta's looking good so far, just from the capital delta. And what else do we have? Dirac delta, Kronecker delta, some interesting functions, right? Chemical shift, NMR spectrograph. Okay. Um, I don't really, I thought there was more interesting versions of delta. Okay, yeah, I think this, I also thought it was the partial derivative thing, this little delta, but I guess it's not. Script delta. Look at that. You learn something new every day. Um, hmm. Am I missing anything? None of these these are all pretty niche, and they're not that interesting niche functions. They're just kind of there. Um, Nevertheless, delta's at least B tier because of, the fact that it represents a difference. Maybe A tier? No, not A tier. It's B tier. Sorry, but it's still good, better than average, right? Okay, epsilon, right? Let's go to epsilon. A small positive quantity. I don't think I've ever seen that, but okay. Um, cool. Permittivity, emissivity. I like both of those. Permittivity and emissivity are both pretty interesting quantities. Axial tilt. See, that's one that's, I'm never gonna use axial tilts, I don't think, but I'm glad to know that it's there and that we have a variable for it. And elasticity. I mean, in economics, I don't really know exactly what it means. I don't know at all what it means in economics, but that's cool. Um, Electromotive force. These are all pretty good, I gotta say. They're kind of niche, not as interesting as all the applications of alpha that are also kind of niche, but I'm pleasantly satisfied. So there we go, it's B tier. Okay, what do we, digamma. I don't even I don't even think I put that in the list, or whoever, made this list didn't put that in the list. But I don't know what this is. Or wow. Digamma or WAU, wow. Um, Archaic letter of the Greek alphabet. Okay, cool. Um, so it's not actually a real letter. You know, that makes me a little bit more relieved by the fact that I've never seen it. Okay, zeta. What do we got? The Riemann zeta function, the damping ratio, or the zeta potential. That's F tier. Sorry. I think the zeta function, I don't really know anything about the zeta function. I've heard it's interesting, but if that's literally all it has, um, then it's still F tier. Cool. Eta, H. eta, which I guess is a capital eta, also represents this thing, the Shannon entropy, which I think regular H, like Latin H, also represents. Anyway, eta, the lowercase one, the one I've actually used. What do we got? Wave impedance. I've never seen it used to represent viscosity, but oh, I like this animation though. Wow. So the left is like water and the right is like what, honey? What flows like that? Interesting. Um, Efficiency is really where I'm kind of approaching this. Um, and I thought there was something else that eta represented. I'm sure there is, but um, because these are only the main highlights. But I thought there was another big kind of thing that eta represented. I'm really not seeing anything that interesting though. Um, yeah, this is not great. I kind of don't want to put it E tier because efficiency is important, but also I use epsilon to represent efficiency half the time. So yeah, this is going in E tier. I'm sorry, eta. Theta, right? Theta's a good. Theta's like the angle, right? Theta's the angle. So already looking good for theta. I don't think I've ever really used capital theta. What do we got? Big O notation. Okay, that's funny. That they use theta instead of O. Well, I guess they still use O for big O notation, but um, you would think they would only use O. Okay, cool. Uppercase theta isn't that interesting. Lowercase theta, though, we got all these angles. Potential temperature. I've never even heard of that. That sounds interesting. Um, okay, cool. And mainly just angles. I thought there was some other stuff that theta represented. Maybe not. Angular displacement, I guess. It's kind of still an angle, but okay. Script theta doesn't really represent much. Okay. Oh, did we skip row or did I just order this wrong? Okay, for some reason rho is here, um, and theta's here, but so yeah, theta being an angle, I gotta give it some credit for that. So I'll put it in C tier. It doesn't have much else going for it, um, but I do use it a lot, so I'll give it some credit there. Okay, let's see. IOTA, inclusion map and set theory, index generator, APL. Okay, and the interior product. These are all pretty bad. These aren't great. Yeah, I mean, hey, correct me if you're out here using IOTA a lot. These are all pretty bad applications, so that's definitely F tier for me. Okay, Kappa. What do we have for Kappa? The Kappa number indicating lignin content in pulp. That's good. You know what? I'm gonna read about that later. Okay. Condition number of a matrix. Okay. Dielectric constant, thermal conductivity. I usually just use K for thermal conductivity. Spring constant. I feel like most of the cases here in which you would use kappa, you could also just use K, and you probably would use K. This is just K but worse, and I already put K in C tier. which isn't great. Maybe that was a little bit harsh of me, but yeah, kappa is not great. In fact, I'm going to put kappa in E tier. Really not that impressed. Okay, lambda. So what do we got for lambda? Ooh, capital lambda doesn't have much to it. Iwasawa algebra. Huh, interesting. Okay, wavelength, sure. Decay constant, sure. Eigenvalue, sure. Those are all pretty good. Wavelength, decay constant, and eigenvalue. I'm impressed, lambda. Poisson distribution, okay. Linear density. I've never seen it for thermal conductivity, but good for lambda if people are using it. Lambda's really catching on, it looks like. These are all pretty good. Wavelength, decay constant, and eigenvalue, and linear density. Again, none of those are good to the level where like regular people would actually use that, but I'm a fan of all of those as variables. So I think I'm going to put this B tier. Yeah, I'll put it B tier. Okay, mu. It's a good one. This one's really popular with the kids nowadays. This one's really catching on. People are using mu a lot more these days. But the thing I like about mu, right, is because it's capital and it's lower. The mu spells itself out, right? The capital's M, the lowercase looks like a U, spells mu. So right off the bat, I'm partial to it. But regardless of my personal opinion, right, let's look into what it represents because that's what's important here. So the Mobius function, never even heard of that. Is it like the same thing as a Mobius strip? Maybe. Cool name though, so I'll give it a couple points for that. The population mean and statistic. It does have some good applications and statistics from the limited amount I've seen. Oh, the fact that it represents micro is also a big thing. Like mu m for micrometers. That's a pretty impressive thing that it managed to pull off. Yeah, that's pretty impressive. Okay, coefficient of friction. I think I already mentioned that way back when I was talking about F. Dynamic viscosity. Yeah, these are all pretty good. Source coefficient, magnetic moment. These are all pretty decent. Again, none of them are great. None of these are great or are that great, but I like it. I almost want to put a B tier. I'm gonna put a B tier just because the whole like fact that it represents like micro is really cool, and I don't think any other Greek letter has been able to do that. So yeah, I'll give it B tier just for that. Anyway, new, right? So frequency, that's the main place I've used it. Neutrinos, no one cares about neutrinos. I'm sorry. Kinematic viscosity is just dynamic viscosity, but worse. And yeah, it's D tier. Yeah, I think it's D tier. It's really not. It has some uses. It's not like I'm never going to use it, but yeah, it's not great. Okay, Chi, or she, or however you pronounce it. I think it's Chi. Sorry, I'm just looking ahead a little bit. Okay, capital Chi with the 3 lines. I've never seen anyone use that. Okay, and lowercase chi, also never seen anyone use that. That's an F tier. Also, can we talk about how difficult that is to write and say to a certain extent? I mean, chi is not that difficult to say, but it's with an X, so it's kind of given me it's confusing, right? Anyway, there's plenty of reasons I dislike chi. If you want to use chi, just use epsilon. I don't see a single situation where that would like confuse anyone. Um, I don't know, maybe I'm wrong, but Omicron doesn't even have anything listed. That is the easiest F tier of the whole list. Wow. What does it even have on its own page? Omicron variants, okay, of COVID. Did we even get that far? Uh that seems pretty bad if we got all the way to Omicron, right? Um, wow. Yeah, okay. Pi though. I guess this is some good news. We all get some pi at the end of the day. Um, I mean pi is iconic because it's 3.14, right? That on its own, I think puts it at least B tier. But let's see what else it has. So, um, not much from what I'm seeing here. I think yeah, the product operator, which is like, sigma, the sum operator, but for multiplication. That's interesting. I mean, I think that's cool, but yeah, not really too interesting with capital Pi. Let's see what else it is. Um, Pion, nucleotide diversity. Not gonna lie, these aren't that interesting. Oh, what is this? This looks like an omega with a line over it, or a B on its side. Oh, Pomega. That is funny. Angular frequency, longitude. Okay. What the hell? Man, these graphs are something else. Okay. Yeah. Um, Again, I'm gonna place a B tier just because, 3.14, right? But it's not really that useful outside of that. Um, I mean, there's a lot here. Maybe I'm completely wrong. None of these are seem that interesting though. Okay, let's take a look at row. Um, of course, we got to get the Gegenbauer functions. I don't actually know what those are, but um, I really just where density. There we go. That's something I actually understand. Density, very important, right? I mean, everyone uses density. It's not quite on the same level as like time or like velocity or anything like that, but yeah, density is very important. Resistivity is kind of important, and I'm not really seeing much else. I could have sworn there was another big application of Rho where I've used it, but I can't really think of much. So yeah, I think I'm gonna have to put uh I'm gonna have to put this in C tier or maybe D tier. No, I'll put it in C tier. Okay, low C tier. Sigma, another one that's been really trending up recently. Before Mu even started trending up. Anyway, this is a big one, right? So we got summation, very important. Um, Big fan of summation. Stefan Boltzmann constant. That's not super important, but it's there. Standard deviation, very important. Stress, also pretty important. Area density, cross section, um, surface tension, maybe surface charge. I thought it was surface tension at some point, but maybe I'm wrong about that. These are pretty interesting. Besides summation, I don't think any of these are particularly important, but there's a lot of I think sigma is useful to each subfield in some way. It plays a big role. So it's kind of in the same realm as alpha in that sense, I think. I don't know if I could put it that high, but I am. I'm going to put it that high. I have to. Okay. There we go. Tau, right? Torque. Mean lifetime, sure. Time constant. Proper time. I always just use T prime for that, but okay. Shear stress, yep. Path tortuosity. Oh, that's cool. I don't know anything about that. You know what? I'll look at that after I look at the kappa number, right? Tortuosity, that's a good one. Um, okay. A protein associated to microtubules. Cool. And precision, the reciprocal of variance. I don't know why you wouldn't just do 1 over, sigma squared instead of having to make up a whole new variable. But good for them. Cool. Mainly just torque and mean lifetime, or, representing time in some sense. I guess if T is already taken, right? Those aren't useless. I guess that's a C tier. I'll put it as a C tier. It might, it feels kind of like a D tier. All right. Upsilon. Great. The Upsilon Meson. Almost as bad as the Omicron section. That's bad. I think the only time I've ever used Upsilon is when I've written new incorrectly and it just looked like Upsilon. I don't think I've ever I don't think I've ever intentionally used Upsilon. That's F tier. Yeah, sorry. Okay, phi. Let's see what we got. Phi is, I think, is pretty important. Um, Work function, flux. I'm a big fan of flux. One of my favorite quantities, I gotta say. And alternative symbol for the wave function. Cool. The golden ratio. These are pretty interesting stuff. Again, nothing that important, I think. The totient function. I like the totient function. I've never actually used it like I've never had to use it, but it's cool. Um, yeah, go take, you know what? I'll read about that a little bit more too. I gotta do a refresher. And then angles, right? It's like the second big angle thing. Radiant flux, neutron flux still counts as flux. I don't really think we need to distinguish. Potential energy sometimes. Yeah, these are pretty good. These are pretty good. And good enough where I'd put it in B tier. I don't know if it's good enough to where I'd put it in A tier. It's not on the same level as sigma or alpha. And I mean, I think sigma and alpha are going to be the two most important Greek variables. I don't mean to spoil the rest of the list. I highly doubt we're going to get another S tier. I mean, yeah. I mean, come on. Come on. The psi and omega are fine. Let's look at chi if it has anything. I don't think it does. Chi squared, I guess that's something. Um, Electronegativity, okay. A character in mathematics. Cool. Mole fraction indicator. Okay. These aren't great. Um, these aren't great. I want to put it in E tier because I have actually used it a few times. I'm not going to tell you in which sense, but use some critical thinking and you'll be able to find um, where I've been using that. But I'm not going to just reveal that. Anyway, let's go on to psi. Um, a symbol for psychology. That is funny. I don't think anyone's ever used that, but good for them for, for making a little Greek acronym. Um, the wave function, that's really the only time I've had to use it. Um, yeah, it's a little bit disappointing. I guess I've used it for the stream function as well. This isn't that great. Besides the wave function, this isn't really bringing a ton to the table. I think it's D tier. It's still better than Kai. I mean, come on. Um, but yeah, that's gonna be D tier. All right, let's finish off strong Omega, right? Let's do it. Okay. Unit of resistance to ohm. That's a pretty big accomplishment. I think I was talking a little bit earlier about how mu was the only, Greek variable that really became a unit, right? Or at least a prefix for a unit with like micro. I guess I was wrong, right? I forgot about the ohm, and that's pretty impressive. So already off to a good start. The omega constant, I've never even heard of this. Um, I'll look at that after. But yeah, that sounds interesting. Um, the solid angle, that's another one that is pretty cool. And Chidens concept. I don't know how to pronounce that, but okay, I don't really know most of these. They seem interesting though. Let's see. Okay, little omega. We got angular velocity. Um, that's pretty angular frequency, angular velocity. Those are decently important. Those are decently not as nearly as important as linear velocity. They're pretty important though. So I'll have to give it some credit for that for sure. And unsaturated fats in biochemistry, omega-3 fatty acids. Okay, that's big. That's big. I'm a big fan of omega-3, fatty acids, right? They're good for, brain health, lowering your risk of cardiovascular disease. And we don't get enough of them. That's the bummer. But I try to get I try to do canned fish. I think is the best way. I know some people aren't big fans of canned fish, but that's a really good source of omega-3 is I usually do mackerel and oyster, right? I like a King Oscar brand. That's the one I go with. This isn't sponsored or anything, but yeah, anyway, shout out to omega-3 fatty acids. Good for them. And I think because of that, we're gonna go and put omega as C tier, right? And let me zoom out a little bit so we can get this all in one. There we go. And I think with that, this is going to be our Latin and Greek variable tier list. Thank you very much.